Okay, next section, series and parallel circuits. There are two types of circuits. First of all, this is not a series or a parallel circuit because it doesn't have enough components to be considered as either. You can only consider something as a series circuit when it's got two components or more. Now in this case we're putting bulbs in there, and these are some classic series circuits. So 2 or 3 bulbs in series. Now here's how series circuits work and the rules for series circuits. First of all, if you measure the current that goes around that series circuit, anywhere around the series circuit with an ammeter, it will be the same everywhere. Now this one will have a slightly different current. Hopefully you should be able to predict this current should be less. And the reason it's less is because there are slightly more, so there are more bulbs, which equals more resistance. So there's less current. And this one, even more bulbs, so even more resistance, even less current. Okay, so that's our third one. So we would expect this one to have the first one to have the most current going through it because it's got the least resistance. This one has got twice as much resistance, so that's going to have half the current. And this one has got 3 times as much resistance, so it's going to have a third of the current. So in terms of brightness, these are going to be slightly bright. These are going to be a bit brighter, and these are going to be. This one is going to be really bright. This one is going to be twice as bright as these two, and 3 times as bright as those 3. Now, if we change that's with exactly the same batteries in each time. So the exactly same amount of voltage coming from that battery. So our rules for series circuits: the current is the same everywhere in the circuit, but something happens to the voltage in these circuits. And the thing that happens to the voltage is if we put a voltmeter in there and measure the voltage of that one and the voltage of that one, and let's say this is 6 volts, it turns out magically that is 3 volts and 3 volts. And then if this 6 volt bulb there, and we work out the voltage of those, then it's split into 3, so it's 2 volts, 2 volts, and 2 volts. And then if we have a look at this one on its own, that's 6 volts, and it's 6 volts. So 6 volt, all the voltage of the battery is split up and is shared amongst the components. So series circuits, current is the same everywhere. And the voltage or the potential difference is shared. Okay, parallel circuits. With parallel circuits, let me just draw these 3 circuits. So we'll start off with just one by itself, which is neither series nor parallel. And there's one with 2, and then we've got the final one. We'll put 3 bulbs. Now, let's move it down there instead so we can see it properly. Okay. So, and the third one in parallel. Okay, now let's imagine we've got the same. We've got 6 volt battery, 6 volt battery, 6 volt battery. Now the thing about parallel circuits is they're all going to be the same brightness. And they're always the same brightness. And one of the reasons for that is because they're also going to be the same voltage. 6 volts, 6 volts, 6 volts, 6 volts, 6 volts. So that's parallel circuit. The potential difference or voltage is the same everywhere. Same everywhere. So that means the current must be the thing that changes this time. Now imagine that you've got some current going through here. 2 lots of current there. One lot goes down there, the other lot goes down there. And they're going down 2 separate paths. And they eventually come back together again to make 2. So let's say that this, for example, would be 2 amps. And that would be 1 amp and 1 amp. 1 amp, 1 amp, 2 amps. Okay, and the same will happen to this. Let's say this is 3 amps. 1 will go down there, 2 will go that way, 1 will go that way, 1 will go that way. Okay, dishwasher's going again. Right, so that'll be 3 amps, 1 amp, 2 amps, 1 amp, yeah, 1 amp, etc. So, parallel circuit, the PD is the same everywhere, the current splits or is shared. Okay, now let's just have a look at one more circuit in where we've got what looks like 2 things going on at the same time. So we've got a series part and a parallel part, and let's see what happens. Now, as our 6 volts goes down here, this time, let's say we've got a certain number of amps. Let's say we've got 2 lots of current, whatever that is, going through there. There's our 2 lots of current. Let's say we've got 3 lots of current. That makes it a little bit easier. Now, this current is going to be split up down the 2 paths. So most of it is going to go that way because it's easier to go that way because there's only 1 bulb. This way, there's 2 bulbs. So it's harder. So there's going to be less current goes down that way. Only 1 lot of current is going to go down that way. We're going to have 2 lots of current goes down this way. And that's going to come back together again to make 3 lots of current. So overall, this part is going to have a bigger resistance, twice the resistance, so half the current. Okay, next part I just want to have a look at is resistors in series and parallel. Now this kind of links into the stuff that we did previously. So let's say we've got a 10 ohm resistor there, and we add it onto another 10 ohm resistor in series, 20 ohms. And unsurprisingly, let's put 3 together, 5 ohms, 5 ohms, 15 ohms. Right, and let's see what happens when we put these in parallel or give the electricity 2 paths to go down. That's 10 ohms and that's 10 ohms. Now in total, our resistance now is actually 5 ohms. So it's something definitely worth remembering. So that's a lower resistance and that is a higher resistance. 20 ohms as opposed to 5 ohms. And the reason is that there's 2 paths for the electricity to go down in this one. So 2 paths there. So that means there's less resistance. And in this one there is more resistance. Now, it's not just resistors that have resistance, it's also bulbs. So let me show you this classic question, which I've seen quite a lot. So there's 2 bulbs in series and 2 bulbs in parallel. The question is, all the bulbs are going to be on, they've all got the same battery, so which one is going to be brighter? And the answer is going to be, this one is going to be the brightest. And the reason for that is, I mean, you can think about the series and parallel result stuff, but the truth is that these two in parallel have less resistance. And if they have less resistance, it means they've got more current. And they've got the same voltage, if you remember. So it means they're brighter. So on this one, more resistance, less current, and we've also got a shared potential difference of voltage, so they will be dimmer. So that'll actually be 4 times dimmer. Okay, all right, let's